it going? Yep, cool. Right, so this is actually going to be a shorter presentation. It was meant to be a second presentation last month. However, we ran out of time due to presentation length, and we just didn't want to keep people here until like 7:40 or whatever. So today you'll be hearing about authentication and authorization. Good, I got the right order. So why did I decide to do this presentation? Well, I've been kind of annoyed by a lot of things. Primarily, you'll see things like this on websites where it's saying, oh, your password's too long, or you have an invalid character in your password, or something like that. And that's just asinine. There's no reason for a password to be restricted by these fields. You should be able to have a password that's 500 characters long if you want. Yeah, well, okay. So part of that is because this, to me, indicates that they're storing these passwords incorrectly. So what is authentication? Well, authentication is really identity, who you are, and verifying that. So I could go up to anybody and say, my name's Patrick Stewart, and they wouldn't believe me for whatever reason, I don't know. And I could go up to somebody else and tell them, I'm John Cena, and they still wouldn't believe me, I don't know. So what authentication is it's basically a way for me to verify who I am. So I can say, yeah, I'm Brian Wernick, here's some information about myself. So with, our normal systems, that is either like an SSH key, that's username and password, email password, or whatnot. So what about authorization? Well, authorization is the second portion of this, and it's actually the one that is more useful, but it does depend on authentication. And this is giving yourself access, or the system giving you access to retrieve information or upload information. So why? Why are these really important? Well, I think we all like to have email or bank accounts, or pretty much any system that you're currently using. You like to have private information stored in there, or maybe it's not so private, it's just information that you don't want others to be able to modify. So it's really important to have both authentication to say, yes, this is me, and authorization to say, yes, of course, I said it's me, so I have access to modify this, but I can't go over here and say, my name's Brian, I'm gonna go modify John's stuff. That doesn't work. John doesn't want that either. So authentication, some examples. Well, Google sign-in, we're all pretty, obviously, Ancestry, since we're here at Ancestry. And even on your Android phone, there's fingerprint sensors, and those actually act as an authentication and authorization mechanism, but we'll focus on the authentication portion. So you've all heard, or I hope you've all heard of basic authentication, also known as basic access authentication. So how does it work? Basically, it's a way to pass your credentials, your username and password, up to a server to verify I am who I say I am, and then the server can either give you content, usually it's a one-time access, or open up a socket. So if you're doing old school like Telnet, you can send your username and password along, and it'll verify those, and then it'll let you open a socket with that system. So the basics of how it works is you take your username or email, whatever that may be, usually it's just a username, a colon, and then your password, all in plain text, and then you base64 encode it. And again, this is just encoding, it's not encryption. So you should definitely be putting this over HTTPS. If you don't, then other people already have access to your accounts. If it is a valid username and password, the server will return a HTTP 200 response with content if you're actually requesting content, or with a connection acceptance. And if it's not, it'll return 401. That's just you're unauthenticated. There is a 403 that I think I get to a little bit later, but 403 is unauthorized. So 401 is unauthenticated. That happens when you're trying to perform a login. 403 happens when you just don't have access to that resource that you're trying to access. Any questions so far? No, pretty simple, great. All right, so authorization, coming back to our Gmail app, pretty much anything like that. So how does this work? Well, it works much the same way. The first few steps are fairly similar. This is a little bit more withdrawn. So if you make a request to a server and you actually need to be authenticated, then it will return a 403 request if you're already logged in, or a 401 if you're not logged in. And along with that 401 or 403, it actually includes a www authenticate header, which tells you that you need to go and get authenticated instead of, sorry, you just don't have access to this. Once you do that, you can go to whatever the login page is for that app. Oops. So if we go back here, that could be, your Ancestry login or your Google sign-in. Enter your credentials, username, password again, and then you send those along to the authentication and authorization server. Sometimes they're the same, sometimes they're not. Usually they're the same. And these credentials can be passed with the basic access authentication method that we talked about in the last slide, or they can be passed along as form content. Again, all of this should be over HTTPS, just so that you're letting that do the encryption for you, so that you don't have to create a custom protocol to encrypt and decrypt your username and password between your client and your server. Once you send those up, if it is a valid login, then the authentication or authorization server will return an access token. So why is an access token useful? Why aren't we just using basic access authentication for all of our requests? Well, the end thing comes down to, you don't really want to be sending up your username and your password every single time you need to request a resource. So thinking of modern day apps, a lot of them are REST endpoints that you're going to hit. So you're going to hit this endpoint and you'd be passing up authenticate header with basic, and then you go to another one, and then you have to pass it up again, and another one, and pass it up again. And each time you do that, you're introducing a point where somebody can capture your network traffic, or the end server, if you don't even trust this secure application, can be seeing your username and password. And that's really not what you want. So an access token can come from this third-party server. So I'm sure a lot of you have heard of Okta or Google Single Sign-On or Facebook Login. All of those will act as your authentication server, and then the authorization portion is pushed onto the secondary, the application server. So in this case, the authentication server will return an access token to your client, the web app that you're interacting with, your Android app, your iOS app, and you store that. And those are valid for however long you want. Usually 30 days is very typical. If you're in a high security application, it might be 24 hours. And then you will be using that access token with a authentication header, but now it's bearer or JWT or whatever format that is in, and sending that to the secure server. And that'll go and connect to your authentication server and verify the token is valid and it's you. And if it is, then it returns your data. So now this portion, the data request with access token and the data response, these are the only two calls that you're going to be, well, the one call and the one response that you're going to be making to all your REST APIs on that server instead of sending your basic credentials up. So access tokens, how are a typical access token, or in this case, how are credentials stored on a server? So for basic authentication, again, you're sending your username, your login, :password, and base64 encoding up to the authentication server. The authentication server is looking at that, and it is adding a salt before or after, doesn't matter. And what this salt does is this salt is a randomized set of bits. Usually you do like 128 bits as a salt. That is the, I can't remember the organization, the National Security Standards something. I can't remember the exact organization, but it's a US national government agency. That's what they recommend, is 128 bits for the salt. And all this is doing is this is adding entropy to your password. Because this salt should be randomized for each individual password that is stored in the database, it means that if they go and crack one, that even somebody with the same password somewhere else, it will be different in your database. So they can't just reuse it. So this is just adding extra security to your credentials on the server. The second part of that is after you've salted the password. Oh, sorry, this password is plain text, not base 64. It could be base 64, I guess, kind of pointless, but you will send it through this PBKDF2, and I don't remember what it stands for. It's a hashing, the one-directional hashing algorithm. For currently, modern implementations are 250,000 iterations per password. So historically, I think it was in 2009, Apple had said that they were using 60,000 iterations. And all this means is you're basically taking the input, so salt and password is the first one, and then hashing that, and then taking that output and hashing that, and hashing and hashing and hashing. And the reason that you're doing 250,000 iterations is because you want this process on a modern day server to take approximately 1 second. And 1 second is because it is long enough that it is going to deter anybody from trying to crack your password through the server, because the server is the only one that knows the exact secret key. And it also is fast enough that an end user is not going to complain about login taking ages. Especially because doing this hashing isn't the only thing you're doing during login. You're accessing multiple servers and doing other things typically. So it's still going to take a couple of seconds to perform a standard login. So now once you have this hash from this 250,000 iterations, this hash is then stored in your database along with the original salt. If you don't have that salt, you will never be able to verify this password. So how do you verify the password? Well, you've stored the hash password that the user set, and you've stored the salt. So now when they try to perform a login with, let's again go with basic access authentication, then they'll send their username and password. You look up the username in the database to fetch the salt and the already hashed password. So then you just take the password they entered, add the salt, whichever end you added it to, go through the 250,000 iterations. That gives you the new hashed password, and then you compare the original, their actual password, to the one that they entered. And if they match, then the login is successful. If they don't, then it's a failed login. So you're wondering, hash password, and then it drops down to access token. Well, part of that's just a bad presentation slide. But so what happens is usually you have this hash password, but that's not what you want to be using at all for a token. That's just something that is stored server side to validate your login. So you can easily create a token. It could be JWT or SAML or some other token format through pretty standard libraries in Java, C#, Node, Python, whatever language you want to do. There's a multitude of libraries out there. And typically these tokens will be split up into a few parts. They will usually have some indicator as to who generated the token. So in this case, let's call it server 1. Got it. It'll of course securely encode that part, so you can decode it, but you can't rewrite it. It has a second part that usually includes some sort of permission structure associated with your token. So that could be read-only permissions for all of the content, or maybe you have write access to API v1, but not API v2. And then the third part is basically hashing the first two parts and including some additional metadata, and then securing that so that you know if the token has been modified. Now on the server side, excuse me, wrong side. On the server side, once you get this access token, you'll want to go back to the publishing server for that and verify that the token is correct. And then you will cache that locally so that when a client makes a network request, you just go and hit your cache instead of constantly going and hitting this authentication server. So that's basic authentication with tokens. So what about OAuth? This is probably the most common and popular one that you will deal with. Google, Facebook, Twitter, pretty much anybody that you can think of is using OAuth 2. Some of them are using OAuth 2 with some additions. Usually that's OpenID Connect, which is a way to do identity parts as part of the token. So that could be basic name, your email, maybe a photo for like a portrait. But right now we're just going to talk about OAuth. And OAuth is very similar to that path that we just talked about before, where you send your credentials to an authentication server. Oops, meant to delete authorization. So that will be to an authentication server. Authentication server will, of course, do what it needs to and return an access token and an optional refresh token. Now, this refresh token can be used later down the line near the expiration, or whenever you really want, should be near the expiration of that access token to go and get a new access token and a new refresh token, so that the user doesn't have to go through the login workflow again, every day, every week, every month, or however often you have these tokens expiring. And again, once you have that access token, then you use the access token to request information from your secure server. Now, I mentioned that this is wrong and it should just be authentication server. And that's because that server, the OAuth server, has no idea about the application. So the authorization mechanism needs to be owned by that application itself. Usually that's handled by storing the permission structure locally to that application. And by that, I mean the server side of that application, not your client side, Android, iOS, web app. And then when you perform a login with your access token, I guess, not really a login, but once you hit endpoints with your access token, then it just goes and hits its local permission to determine if you can access or write or whatever those resources that you're trying to. So why is OAuth popular? It's because it's a very open standard. It's simple to understand, and it's been proven to be pretty secure. Now, there are downsides to it, but for the most part, we all understand, there's upsides and downsides to any authentication and authorization mechanism. And my thing's not working anymore. Here's my mouse. I think I lost the slide somewhere. Okay. So I was going to talk a little bit about different token types. So there's the access token that I've already explained very thoroughly. The refresh token, that's pretty simple. There's also another one with OpenID Connect, and that is called an ID token. This ID token is what is passed between your client, so that could be your application, your Android application, your iOS application, and the server to go and retrieve this basic information that's identifying. So your first name, last name, email, a portrait, whatever information that you have defined that you want them able to access. So going, I don't know if that's true. No, it's not working. So going back to the Google login, a lot of times when you see Google login, along the top it says, this application is requesting access to, and then it lists a couple things like, your display name or your email address or whatever. So that is actually using OpenID Connect, the identity token, to allow the server application to access those resources. And that's all I have. Any questions?
Yeah, so with the salt storage, does that have any possibility of going back to the client, or is it basically stored on the server end and pretty blocked from going back?
The salt should never be returned to the client. Sorry if my mouse would. There we go. What was it? Oops. So in this case, the salt, where is it? Oh, there it is. The salt is a server side. It's kind of this key that the server knows about.
It's not unique for each.
It is unique for each user, or for each login, for each credential stored in the database. And it can be sent to the clients, but typically you don't want to do that because that gets rid of the extra entropy that you're achieving by adding salt.
So, but salt, because you have to use it before you can actually get your hash method, it's going to be stored on technically a slightly public server, but closed off because you usually don't know the address.
Right. Okay. Yeah. So what the salt really helps with is and this happens fairly often, a lot of times we don't hear about it, if a database backup goes missing or is copied, then the people that have access to that database copy, if they didn't encrypt the database, which also happens, have access to all these hashed credentials, but that doesn't really do much for them.
Yeah.
Because they don't know the original password and they don't know the interaction between that original password and the salt. So they can see the salt because that's stored in the database, but they can't use rainbow tables, which is basically a way to quickly look up hashes based off of input to calculate what their passwords were.
How does like two-factor authentication come into play? It's just an extra step, isn't it?
Yeah, two-factor authentication it kind of sits around here, where it hits another server, and I can't remember the exact protocol that it's using, but it might be using some sort of OIDC or some sort of access token or something like that. And so it goes and hits a secondary server, and that server is what is configured with you as a person to identify yourself. So usually that's like the Google Authenticator app or your mobile phone, which, by the way, try not to use your phone number as a two-factor authentication. And I'll get to that in a moment. So it'll use one of those services to go and verify it is who you are. So when you enter, this 4 to 6 digits or whatever it is, then that goes and says to this server, oh yeah, this person just entered this. So that indicates that they are the ones actually trying to access this resource.
But if you get the token, it doesn't matter if they have 3 or 4 factor authentication.
So it'll be a different token. It won't be like the user's access token, but it'll be a token that is sent between the two-factor authentication server and this.
Right. I'm saying if you have that token though.
Oh yeah, if you get the token, you have the token.
How many
Right.
So if you're making unsecured network calls.
Yeah, if you're going over HTTP, which you shouldn't, and this is why Google is doing a big push to get everybody to HTTPS, you're kind of SOL because you're leaking all sorts of data. So, you had a question?
That one's more or less along the HTTP and HTTPS, like how do you actually maintain it straight? Because every time I build a website, I've created an HT access doc, but I haven't ever been able to completely eliminate the HTTP part for my website. So I've just, it's more or less something I've been wondering.
Yeah, so basically anytime you have secure content, you'll want to use HTTPS. And in order to not leak your credentials, don't send them over HTTP.
I just mean, how do you enforce it so that they can't even access a page with HTTP site?
Well, so if you have access to the server, you can just have all HTTP redirected to HTTPS.
That's your best one.
That's the easiest one usually, yeah. Because then they try to access it one time and then they get rerouted to HTTPS and the rest of their communications through HTTPS. You can also configure servers to reject HTTP connections.
Huh.
But,
I'll have to look into that one.
Yeah. So phone numbers and two-factor authentication. Don't do that because my thing's going to go to sleep here in a moment. There is so it's easy to hack people. So if you go and talk to somebody and you're like, oh, I lost all my stuff, I can't access this and this happened. People are going to start to either get annoyed with you and want to get rid of you as fast as possible, or they're going to feel sorry for you. And so what happens is people will go into like a phone dealer or Verizon or Sprint or AT&T or whatever, and go to them and like, I lost my SIM card, and get them to set down their phone and then get them to take his account and put a new SIM card into my phone that is now linked with his account. Then I can go over here and go, trying to log in as John, two-factor. And so don't use your phone number as a two-factor authentication portal. Use an app like Google Authenticator, or they have YubiKeys or anything like that. Kind of a non sequitur.
Just out of curiosity,
yeah.
Whatever you just explained or the example, is there any incident that happened?
Oh yeah.
Oh yeah.
Yeah.
Really?
You know the DEF CON, so at DEF CON where this lady, she put on a YouTube video of a baby crying, called up the telephone company and reset the password, locked the other person out of the account who was recording the story, and all without having any of the information.
Yeah, if you haven't already done it, call your provider.
Yeah.
And they will set it up. You have to have a PIN.
Yeah.
To change anything like that, to get a new SIM card or anything like that.
If you're using Google Fi actually has additional authentication built into it, so you don't really have to worry. But if you're using a standard like physical SIM card, then you should call and if you call them and tell them, oh, I have to have my PIN to do it, you can still hack an individual that you're calling and talking to on the phone, but hopefully it's more likely that they will require the PIN. Yeah, there's definitely instances of it happening. There's actually a few people that I work with that had it happen to them, and they lost a lot of money in cryptocurrency because of it. Can't get that back. Yeah, you can't get that back. So.
Can they block it out though, so that money can't be used?
No.
They can have some no Bitcoin.
Not that I've read.
Not the popular ones.
So did you hear about Facebook's 2009 storing passwords in plain text?
So
what was happening there?
I didn't actually read the article, but my assumption is logging.
Yeah, and I heard a little bit about that.
Yeah, this happens all the time too. So it's not just Facebook. I bet you Google and Apple and like any major company has done it, just because it's easy as a developer to miss something. And realistically, what that was most likely happening is during development, something was going wrong in this area, and so they added logging to log like the salt and the raw password.
Really?
It's happened. I've seen it at a couple of companies. And so you just log it as plain text, like, it's fine. It's just in development, and then you're miswrapping it around like a development flag or something like that, and it gets into production. Okay, it's still on the server, so it's not as bad, but we should get rid of it. And then somebody gets access to your server, or can get the logs somehow. Then all the raw credentials are leaked. So that's most likely what happened. I don't know. I didn't actually read into it.
Yeah, it was just something I heard on the news once when I was listening to. I'm like, might as well ask someone about it later.
Any more questions? Doesn't have to be the
I
only
know
time.
we just implemented like federated login,
Yeah.
federated services. And that's just, I guess that's just as simple as you're redirecting, instead of using your own authenticator.
Yeah,
you're
so
redirecting
what
to another
Federation is
authenticator.
doing is it's using an OAuth server to act as a hub for other OAuth clients.
That's what
And so they're all coming into this one, and then that one is basically giving all the access tokens and identity tokens and whatnot out. That's really what Federation is, which is really cool. Single sign-on.
One thing that sucks is you can't rip out our fingerprint
Really?
sign in to go with federated stuff.
Cool. All right then.
Right?
Is there a way? Would there be a way to securely? You still use the fingerprint
With Federated?
with federated?
I believe you can. I don't know why you would have to rip it out unless there's some restriction added to the policy that would cause that.
I think what it is because we only pass up the email, and our authenticator checks the email, looks it up, and says, "Oh, this goes to this federation," or it's ours. So we don't actually, the user never actually enters the password on
Yeah.
our side.